This lesson is about functions. A function is a rule that assigns one output for every input. In other words, you plug in a number and you get back one answer. We're going to look at three different kinds of functions. First, we're going to make a table with input values. X is always the input or number we plug in. So we're going to plug in -2, then -1, then 0, and then 1. You can plug in really any numbers. First, we're going to look at what a linear function is. So this linear function, f of x equals 2x plus 5. Notice it's a lot like slope-intercept form, which would have been y equals 2x plus 5. And it has most of the same characteristics. The 2 would be the slope, how much it's going up each time, and the 5 would be the y-intercept. But we're going to try treating this like a function and plugging in each input. So we're going to first plug in -2 where the x is and find the answer. Then we plug in -1, 0, and 1 and get the answer or output for each of those inputs. The pattern we notice with linear is that it's always going to add or subtract the same amount each time. On this one, it's adding 2 to go from 1 to 3 to 5 to 7. This is a linear function because it has a constant difference. It's exactly like how we recognize arithmetic sequences. Next, we're going to look at an exponential function. An exponential function has an exponent of x. G of x is equal to 8 times 1/2 to the power of x. This looks very similar to geometric sequence formula that we've used before. When we plug in -2, -1, 0, and 1, we end up with the values 32, 16, 8, and 4 as our outputs. These also have a very distinct pattern. Notice that every time we go from one output to the next, we are dividing by 2, or in other words, the next one is half of the one that came before it. This means it has a constant ratio of 1/2, just like how we recognize geometric sequences. If it is multiplying or dividing by the same number each time on our output values, then it is an exponential function. Now we're going to look at something completely new, a quadratic equation. Quadratic has a power of 2 in it, so h of x equals x to the power of 2 minus 5. This one's not going to be linear or exponential, but something different. When we plug in -2, -1, 0, and 1 into this equation, we get back the outputs -1, -4, -5, and then -4. Notice it's first decreasing, then increasing. When we look for the common or constant difference, we notice that there isn't one. First it goes down 3, then down 1, then up 1. But what makes the quadratics easy to find is that you need to find what's called the second difference. From -3 to -1, it's going up 2, and from -1 to +1, it's going up 2. So that 2 is called the constant second difference, because even though we found the difference between each value and it was not the same, when we found the difference again, that one was the same number each time. Another thing we need to be able to do besides recognize which type of function it is compare the values. You'll notice as you compare each of the values, the exponential function always seems to be bigger until we get to the bottom. In that case, the linear function all of a sudden is greater than the exponential function. So if we look at all of those values we found, you can see that sometimes f of x is greater than g of x. Remember, f of x is what we called our linear function, and g of x is what we called our exponential function. But the quadratics are all negative. In this case, h of x is always going to be less than g of x. Whenever you're going to compare functions, make sure you look at every single value in the table and see if they're always greater, always less, or if they're sometimes greater and sometimes less.